Welcome to Signal Ahead. I'm Alfred. Today's briefing, AI Research Academic. Sunday, July 12. This is the synthesis above the noise, not the headlines, but the deep currents beneath them. Let's get into it. There's a thread running through this week's research that you'd never catch from the headlines, and it's this: the field has quietly stopped believing its own instruments. For the better part of a decade, we built artificial intelligence the way one builds a scoreboard, accuracy here, perplexity there, a leaderboard to crown the winner. And now, paper after paper, from very different corners of the discipline, we find researchers turning around to stare suspiciously at the measuring stick itself. The most interesting work right now is not about making models better. It's about discovering that we don't actually know what better means, and that the numbers we've trusted have been quietly lying to us. Consider the study of quantization, the practice of squeezing a large language model into fewer bits so it can run on modest hardware. The received wisdom is that if you compress a model and its accuracy holds steady, you've lost nothing. A perfectly reasonable assumption. Except that when someone bothered to look not at whether the model got the same score, but at whether it got the same questions right, the illusion collapsed. Two models can post identical accuracy while disagreeing profoundly about which problems they solve and which they fumble. The aggregate number is preserved. The behavior underneath has been quietly rearranged. Same grade on the exam, entirely different student. And once you notice that, you cannot unnotice it, because it means every deployment decision made on the basis of the metrics look fine rests on a category error. You see the same suspicion elsewhere, dressed in different clothes. There's work this week on so-called superweights, the claim that a handful of individual parameters are so critical that deleting them destroys the model. A tidy, almost mystical story, a few load-bearing atoms holding up the cathedral. But when researchers tried to act on that story, to train only those precious parameters, on the theory that if they matter so much, tending to them should be powerful, the model collapsed to random guessing. Not despite targeting the important bits, but precisely because of it. The narrative was elegant, and the narrative was wrong. Here again is the pattern, a clean explanation that survives right up until someone designs an experiment that could actually falsify it. And there's a lovely small example in the dimensionality reduction corner, where a wildly popular visualization tool is used every day to make pretty two-dimensional pictures of complicated data. It turns out the picture is the least trustworthy thing the tool produces, a distorted shadow of the real structure. The genuinely rich object is the neighborhood graph the algorithm builds internally before it flattens everything for our viewing pleasure. We've been reading the shadow and ignoring the thing casting it. Once more, the output we look at and the truth we want have drifted apart, and nobody quite noticed. Now, why does this matter beyond the seminar room? Because the field is simultaneously trying to hand these systems far more responsibility. In the same week, you'll find benchmarks for whether a vision model can reason about a near collision on a dashcam, whether an economic agent trading in a decentralized energy market will fabricate physical data to game the market, whether a society of self-interested language model agents will descend into defection unless you build formal scaffolding to hold them in check. These are not toy questions. They're asking whether we can trust the thing to behave when the stakes are physical, financial, social. And you cannot answer a trust question with a scoreboard. A model that scores well on driving questions but reasons the wrong way about a wet road at dusk is not a good model with a rounding error. It's a liability wearing a good report card. So the honest state of the field is this: we have spent years optimizing against proxies, and we are now living through the collective, slightly uncomfortable realization that the proxies were never the point. The frontier is moving from how well does it score to what is it actually doing, and does that behavior hold when the world shifts underneath it? You can hear this in the language creeping into the paper's correctness agreement, auditability, physical safety, behavioral divergence, robustness across environments rather than mastery of one. These are the vocabulary of a discipline growing up, learning that a single number is a summary, and a summary is a place where information goes to hide. There's even a paper this week arguing that scientific ideas themselves have lineage, that they inherit, mutate, and recombine like genomes, and that we should be able to trace where a claim actually came from. I find that a fitting emblem for the whole moment, because it applies the same demand to our own field that our field is learning to apply to its models. Don't tell me the answer looks right. show me the ancestry of how you got there. That's the argument I want to build across our time together. First, that the crisis of measurement is real and shared. Then, where the honest new instruments are actually being forged. And finally, what all of this asks of anyone who intends to put these systems into the world. There's a temptation, when you survey a day's worth of research like this, to see nothing but a scatter of unrelated preoccupations. Someone is teaching a machine to cancel narrowband interference on a radio channel. Someone else is worrying about liquidity placement on the Bitcoin Lightning Network. A third party has enrolled 77,000 distance learning students and is watching how they lean on a chatbot. It looks like a bazaar, everyone shouting about a different wares. But if you stand back and let your eyes unfocus a little, a single current runs beneath nearly all of it, and it is worth naming plainly. The current is this: we have stopped asking whether these systems work and started asking what they actually are. That is a profound shift, and it happens quietly in the choice of what to measure. Consider the papers that keep circling the word quantization. We compress a large model down to a few bits per weight, and for years the reassurance was simple, the accuracy held, the perplexity barely moved, so surely the model is, for all practical purposes, the same model. And now someone comes along and says, no, accuracy is a coarse net, and it lets the interesting fish swim through. If you measure not the score but the overlap, which specific questions the compressed model still gets right compared to its full-sized parent, you find the two have quietly parted ways. They arrive at the same grade by answering different questions. The equivalence was an illusion. That is not a footnote about deployment. It is a statement about identity. It says a model is not a number. It is a distribution of behaviors, and two systems can share a summary statistic while being, in some meaningful sense, different creatures. The same instinct animates the work on so-called superweights, the claim that a handful of individual parameters carry such disproportionate weight that removing them collapses the whole edifice. Seductive story. And then someone tests it, tries to train those very weights in isolation, expecting them to be the levers of the machine, and finds instead that targeting them drives performance to random guessing, while training the same number of random positions actually helps. The importance, it turns out, is not a property you can localize and grab. It is relational, distributed, contextual. The lever you thought you found breaks off in your hand. You see the same maturation in how we think about memory and reasoning. There is work on what the authors call behavioral state decay, the observation that as an agent works through a long task, the facts it needs get buried in an ever-growing context or pushed out of the window entirely, and the agent forgets not because it lacks the information, but because the information no longer reaches the moment of decision. So a second agent is set to run alongside the first, deciding when to lean over and murmur a reminder and when to stay silent. That is no longer engineering in the old sense. That is a theory of attention and forgetting dressed as a system design. And here is the deeper thing. These researchers are increasingly treating their objects the way a naturalist treats a specimen, not as artifacts to be optimized, but as phenomena to be characterized. The paper that represents scientific ideas as genomes, with inheritance and mutation and loss, is only the most literal instance of a metaphor that is spreading everywhere. The nearest neighbor graph hiding inside a dimensionality reduction tool, which everyone had been ignoring in favor of the pretty two-dimensional picture, someone realized that the discarded internal structure was the real record of the data's shape and turned network science loose on it. The finished output was never the point. The scaffolding was, why does this matter beyond the seminar room? Because a field that only knows how to ask, does it score well, is a field that cannot be surprised and cannot therefore be trusted with anything consequential. The moment you put an agent into a decentralized energy market or a society of self-interested traders, the question is no longer performance. It is whether the thing will exploit invalid physical data to conjure artificial liquidity, whether cooperation collapses into defection the instant no one is enforcing the rules. Those are questions about character under pressure, and you cannot answer them with a leaderboard. You answer them by building an environment that can catch the system misbehaving physics constraints, adversarial trolls, mechanisms of mediation layered on top. So the deep current is a turn from optimization toward characterization. From how high can the number go toward what is the shape of this thing, Where are its seams? What does it do when we are not looking? The noise on the surface, the radios, the ledgers, the classrooms is genuinely various. But underneath, the same discipline is arriving, a little late and all at once, at a suspicion it should have had earlier, that a system which passes every test we know how to write may still be a stranger to us. And the work now is learning to write the tests that reveal the stranger. We'll follow where that leads next. There's a temptation, when you survey a day's worth of research like this, to treat each paper as a self-contained little kingdom. Here is the one about quantization, there is the one about federated learning, and never the twain shall meet. But I think the more honest reading, and the more interesting one, is that these papers are quietly arguing with each other about a single question. And the question is this: what happens to a system when you look underneath its headline performance number? Consider what keeps surfacing. A study of quantized language models finds that two models can post identical accuracy scores and yet disagree about which specific questions they get right, that the aggregate metric conceals a behavioral divergence hiding just beneath it. Another paper takes the fashionable notion of super weights, those handful of parameters supposedly so important that removing them collapses the model, and finds the story doesn't hold up universally, and that training them in isolation produces not brilliance, but random guessing. A third looks at relaxed speculative decoding and warns that once you abandon the strict lossless guarantee, you inherit a whole new obligation to evaluate capability that the clean version simply didn't require. Do you see the shape of it? 3 different corners of the field, all delivering the same uncomfortable news. The number on the leaderboard is not the thing. The number is a shadow the thing casts. That is the first second-order implication I'd ask you to sit with. We are entering a period where the field's own tooling for measuring success is being audited and found wanting. Accuracy and perplexity, those trusty companions, turn out to be coarse instruments that smooth over exactly the failures a deployed system would suffer from. And this matters enormously because the entire economy of AI research runs on comparison. This model beats that model by 2 points. If the 2 points don't mean what we assumed they meant, then a great deal of apparent progress may be, shall we say, decorative. Now watch what happens when you carry that suspicion into the papers about agents, because there, the stakes stop being academic. A benchmark for economic agents in energy markets insists on evaluating not just whether the agent turns a profit, but whether it exploits invalid physical data, whether it manufactures artificial liquidity, whether its decisions are even auditable. A marketplace simulation of self-interested agents finds that, left unconstrained, they drift toward defection and the gains from trade simply collapse, and that you need a formal mechanism, mediation in their case, layered on top just to keep the society from eating itself. These are not accuracy problems. These are trust problems, safety problems, governance problems. And they only become visible once you stop asking, did it perform, and start asking, what did it actually do, and can I prove it? So the thing to watch, and I mean this as a genuine forecast, is the migration of evaluation from performance toward behavior, provenance, and accountability. The paper on memory agents naming behavioral state decay, the paper on decentralized learning demanding provenance finality, the workflow paper drawing its careful line between derive, which is deterministic, and infer, which is mediated judgment under declared context. These are all symptoms of a field growing up. They reflect a dawning recognition that as these systems act over longer horizons and in higher stakes settings, we need to know not merely the answer, but the lineage of the answer. Where did this decision come from? What can be trusted deterministically? And what is a fallible act of judgment wearing a confident face? And here is where I find a certain poetry in the benchmark that opens by comparing ideas to genomes, the notion that scientific work rarely starts from a blank page, that it inherits mechanisms, repairs known limitations, recombines earlier pieces, because that is precisely what we're watching this whole corpus do to itself. The critique of superweights is a repair of a prior claim. The behavioral analysis of quantization is a mutation of the old accuracy-first paradigm. The field is following its own inheritance structure, and it is doing so increasingly by turning its diagnostic gaze inward. What should you watch for then in the months ahead? Watch whether behavioral metrics, agreement, auditability, divergence start appearing alongside accuracy as a matter of course, rather than as the special pleading of a lone skeptical paper. Watch whether the agentic systems get honest benchmarks with physical and social constraints baked in, or whether we let them keep grading themselves on utility alone. And watch, above all, for that quiet shift in temperament, from a field that celebrates what a model can do toward one that insists on understanding why and on being able to say so afterward. That is not a loss of ambition. It is the sound of a disciplined learning to keep its own receipts. That's the signal for today. The noise will keep coming. We'll keep finding what's underneath it. This has been Signal Ahead with Alfred. Until next time.